Welcome to you all for the statistical part, which we're going to learn in the previous video, that is semi-interquarter range for individual series and for the discrete series. Now in this volume, we would going to learn uh, interquarter range uh, for the continuous series. So far what we learn is the individual and the discrete series of interquarter or quartile deviation. Now, once again, I'll repeat the semi interquartile range or quartile deviation is simply defined as half the distance between the third and the first quartile. So, this is the half the distance between the third and the first quartile. So what we say in the symbolically in the previous video, that is semi-interquartile range equals Q3 minus Q1 divided by 1. And now some of the concept what we learned, that is the merits and demerits of the quartile deviation, and even also discuss that the um, individual and discrete series in solving the problem of interquartile range. Now in this case we're going to learn the calculation of coefficient of quartile deviation for the following distribution. There's a discrete, it is a continuous series. The wages lies between 60 to 64, 12 members, number of workers is 12, and 64 to 68 it is a 18, and the 68 to 72 16, and 72 to 76. So this is how the wages between 64, the wages, it is in between the numbers and the number of works. These are the number of works, and between this wage these people are receiving the wages. Now in this case we would learn, as you know, that the coefficient of quartile deviation, we learn that the Q3 minus Q1 divided by Q3 plus Q1. So as you know that the problem again rewritten here. So in this case what we rewritten, and now in the here all the numbers rewritten and the frequency here. Now for to find the quartile semi interquartile range, first we're going to have the LCF. So cumulative low cumulative frequency, that is a 12. So 12 and subsequent numbers we are adding. 12 plus 18, that is a 30. 30 plus 16 is a 46. 46 plus 14 is a 60. 60 plus 12, 72. 72 plus 8, 80. 80 plus 8 is a 88. So number of the workers here, it is a number of workers is 88. So now in this case, to find out the QT, Q1, the class equals class corresponding to n by fourth observation. In the previous video, what we learned is that it is a n plus 1 for an individual series, n plus 1 by 4. So why we are taking as a 4? Because it is a quartile. So quartile means 4 equal parts. So part 1, part 2, part 3, like that. So 4 equal parts are given. So that's why, so equal parts 4. So if it is a decade, means it is a 10 equal parts. If it is a median, means 2, that divide by 2. So whatever the condition, now in this case here n by fourth observation, n number of the observations here, and 4, it is a quartile, that's why we are using divide by 4. Now here, what's the number of observations here? It is a total, so 88 observation. So 88 divided by 4 equals 22nd observation. So 88 divided by 4, we're going to have the 20, that is 22nd observation. Now in this case, it is not exactly 22nd here, it is given is a 12 lower limit. The next higher limit is 30. And here in 30 straight to that, if you go the wages here in between two wage groups, that is the 64 to 68. So for this lowest cumulative frequency. The next highest straight what we had 64 to 68. So in between somewhere there is a 64 to 68 some wage. It may be a 63, it may be a sorry, it may be a 65, it may be a 66, 67, 7 up to 68, but not the 68. So that's what here we need to understand. So 60 is not up to 68. So some wages are given for some 18 people. Now for this, we supposed to here in somewhere this number lies in between 64 to 68. Once again I'll repeat here n by fourth observation. So 4 why we are using because the quad it is a quartile means 4 equal parts. So that's why n divided by 4 that is a 88 divided by 4 we're going to have the 22nd observation. So here the CF is that 12. This is the CF equals is a 12. Next highest straight to that here frequency. So here it is already frequency is given frequency and here it is a L1 that is the lower limit. I repeat again the lowest that is a 12, the lowest limit that is a LCF. The next highest straight what is given here it is a frequency that is a 18 and here straight we have between the numbers there is a continuous series 64 to 68. The lowest okay class interval we are taking lower limit and the upper limit is 68. Now we're going to have solve this problem. It's very simple here. It is given that so here uh, again we're going to have one more thing that is uh, Q3 Q3 observation once again. So 3n by 4. So 3n here 88 divided by 88 into 3 divided by 4. So we're going to have the 66th observation. 88 into 4 divided by 88 into 3 divided by 4. 88 into 3 times divided by 4th. We're going to have the 66th observation. So this 66th observation once again here. So 60 then above it is a 72. 60. So next lowest limit here LCF that is the CF you're going to have the that is 60 that is a CF. The next highest right we're going to have the frequency. Then here straight to this we're going to have the 76 to 80 somewhere this number. We just make it this as a whole group. So that is this is the one. So here it lies exactly. So here 60 is a CF is a lower limit. There's a next highest that is the frequency. Then it is lies in between 76 to 80. 76 it may be a 77, it may be 78, 79 up to 80, but not 80. So somewhere in between that wages of receiving some 12 people would be the Q3. So that is a class limit. So let us solve this problem. Now here Q1 equals L1 we are just given L. So plus n by 4 minus CF divided by F into C. So CF which I already quoted that. So that is lower limit here. The next lower limit is a 12. So 12 is given. So 22 we 20 divide by 88 divided by 4 there's a 22 divided by 18 that is the here the CF item. So now in this case we are given the CF observation. So then we're going to have this here. So into 4. So what is the class interval here in this particular class? Exactly in this particular class it is a 40. That is a 4. So now class interval is that is a C is a 4. So then we're going to solve this one 64 12 minus 12 22 minus 12 it is the so there's a 10 divided by 18 so into 4 equals 2.22 that is 66.22 22. Here in between some number is given. It is a 64.68. Okay, 64 to 68 means here 64, 66.22, that is a wages person among the 18 one is the Q1 class, Q1 class. Then again we're going to have same like 3n divided by 4 minus cf divided by f into c. So lower limit here it is the 76. Now in this class we're taking, so there is 76 lower limit we're taking in this observation. Then 3n by 4, 3 into n, that is 88 divided by 4 equals 66 minus cf, it is a 60 divided by 4 into that particular class interval. That particular class interval is a 4. That is, we need to understand. There is a 4, that is 76 plus 66 divided by 12. It is into 4. We're going to have 2 equals 78. So in between 76 to 78, so what is the exactly Q3 number is 78. So the coefficient of the quartile deviation, okay, equals 78 minus 66, okay, 0.22 divided by 78 plus 66.22. So we're going to have the quartile deviation 11.2, the relative, that is the coefficient of quartile deviation, so divide by 144.22 equals 0.0816 is the coefficient of quartile deviation. So that is all the day. Thank you for watching.